Envision an enormous ensemble, played by an endless number of stars, planets, and moons, all proceeding as a bound-together opening. In any event, there is one particular area of this gathering that has confounded cosmologists for a genuinely drawn-out period: exoplanets. These are planets that exist outside our planetary system, stowed away somewhere deep in the Milky Way. You may be astounded to find that, among the vast number of cosmic objects, there are exoplanets so like Earth that the story veers off in an unexpected direction, especially like a sci-fi thriller. Specialists using the James Webb Space Telescope found something astonishing from Proxima b, a signal so unusual that it moved throughout the informative segments in research networks. It was named a potential technosignature, a signal so bewildering and intricately arranged that it could potentially indicate the presence of a high-level civilization. The collective heartbeat of humanity seemed to pause at the zenith of an announcement that promised to change our perspective on reality. Could the signal be the clearest evidence that we are not alone in the universe? Just as quickly as it appeared, the signal dissipated without reappearing, leaving behind not just an overwhelming silence but also a labyrinth of unanswered questions and pervasive speculations. Was it simply a transient natural phenomenon, a result of cosmic activity, or something else entirely? Intentional, perhaps? A coded message? Or even a signal from an advanced, potentially disturbing civilization? This single mission cast a shadow of doubt over Proxima b, igniting a heated discussion. At its core, was it simply a fleeting irregularity, or part of a larger, far more bewildering narrative? This narrative, a woven masterpiece of our boundless inquiry, remains unfinished. The ink has not yet dried, and new chapters are still being written. This time, it isn't just conventional researchers, but Harvard specialists, who are leading a paradigm shift in our search for extraterrestrial life. They're not merely analyzing the signs and signals we've observed so far. They're expanding the scope by transforming the James Webb Space Telescope into an advanced night vision telescope. Their goal is to search for artificial light sources, both in the faint and illuminated regions of distant universes. Imagine spotting the bright lights of a city, an urban landscape glowing amidst the cosmic darkness, hinting at the presence of a high-level civilization. As we continue to unravel the universe's secrets, the quest for extraterrestrial life takes on new dimensions, transcending the brief fascination with Proxima b. Our search delves deeper into the mysterious expanses of space, driven by groundbreaking advancements and an unrelenting curiosity about our place in the cosmos. Continuous progress in cosmology and space exploration has led to the discovery of many exoplanets with a potential for habitability. Instruments like the James Webb Space Telescope, JWST, and ground-based observatories have greatly enhanced our ability to detect and study these distant worlds. One especially intriguing field of study is the search for biosignatures, indications of life. These markers could include atmospheric gases like methane or carbon dioxide, which, under the right conditions, could signify biological processes. The JWST's capabilities go beyond basic discovery. Its advanced instruments can analyze the atmospheric composition of exoplanets with remarkable precision. By studying light that passes through an exoplanet's atmosphere, experts can identify chemical markers indicative of life. For example, the presence of water vapor and other molecules, like oxygen or ozone, might suggest conditions favorable to life. Another line of exploration focuses on the conditions of these distant worlds and the search for technosignatures, which have gained traction. These are indications of advanced civilizations, visible through artificial structures or advanced technology. Such markers might include megastructures, like Dyson spheres, designed to capture a star's energy, or unusual patterns in radio transmissions. As we refine our observational methods, the search for technosignatures could reveal the existence of extraterrestrial intelligence. Not only groundbreaking developments but also global collaborations are crucial in the quest for extraterrestrial life. Partnerships among space agencies, research institutions, and private entities bolster our capacity to explore space. Missions to Mars and other celestial bodies are fueled by contributions from multiple countries, pooling resources and expertise to achieve shared goals. Public engagement and education are also key, as the excitement surrounding space exploration drives the future of scientific research and learning. New technologies further enrich our understanding of the universe. Advances in telescope design, data processing, and computational models improve our ability to identify and study distant exoplanets. Cutting-edge space telescopes, such as the Extremely Large Telescope, ELT, and the Habitable Exoplanet Observatory, HABEX, promise even more detailed observations and deeper insights into the potential habitability of exoplanets. As we push the boundaries of our knowledge, each discovery raises new questions and areas for investigation. The search for extraterrestrial life isn't only about finding alien civilizations. It's also about understanding the origins and diversity of life across the universe. It challenges our perceptions and broadens our ideas of what it means to be alive. The study of exoplanets and the search for extraterrestrial life are dynamic, evolving fields. With every step, we edge closer to answering some of humanity's most profound questions. As we continue exploring the universe, the potential for discovering new forms of life and understanding our place in the cosmos remains boundless. Tantalizingly similar, yet bafflingly different, Proxima b might be Earth's twin. Located 4.2 light-years away, the James Webb Space Telescope guides our journey to understand these cosmic mysteries. Imagine, for a moment, your mind traveling across the vast, majestic expanse of our universe, the Milky Way, home to more than a quadrillion exoplanets. To put this number in perspective, if each exoplanet were the size of a grain of sand, we wouldn't merely fill the Grand Canyon. We'd have enough to create another landmark on Earth, a Grand Canyon 2.0, extending for an immense distance. Most astonishing of all, about 20% of these celestial bodies are considered Earth-like in terms of landscape and environmental conditions. That means there's a 1 in 5 chance of finding a twin of our planet. And the story doesn't end there. Alongside these planets, there could be another quadrillion moons, harsh satellites like our moon, engaged in gravitational dances with their parent planets. If you somehow manage to find another body in space that harbors life or could potentially do so, the universe offers a flood of opportunities. Now that we have outlined the vastness of this cosmic tapestry, it's time to introduce the masterwork, an instrument designed to reveal its diverse details, the James Webb Space Telescope. This magnificent Sherlock Holmes, with its impressive focal length, surpasses even the most advanced Marfan optics. We're not talking about any lens. Its 6.5 m primary mirror is 2.7 times larger than Hubble's. Imagine the finest detail it can recognize, even the faintest flicker of a star billions of light-years away, and then analyze the details of orbiting planets. What makes the James Webb Telescope revolutionary is not just its seeing power, but also its cutting-edge technology, including forward sensors and spectrographs. These instruments can do much more than observe. They can analyze and filter the unique light signatures emitted or reflected by celestial objects to unravel their atmospheric conditions, density, and even mass. Acting as a space investigator, they can determine if a planet has water, organic compounds, or even oxygen. The James Webb Space Telescope can answer these questions, elevating it from a simple observer to a scientific genius. It's more than an improvement over its predecessor, Hubble. It's more like a quantum leap. If Hubble's discoveries stunned you, prepare for a genuine burst of cosmic revelations. As we broaden our view across the vast expanse of the universe, it's worth focusing on one specific star in the grand show, Proxima b. Since its discovery in 2016, this peculiar planet has stood out as a Shakespearean legend filled with intricacies and mysteries, captivating space experts and astrobiologists alike. What's the big deal? Above all, Proxima b is fundamentally in our galactic neighborhood, just 4.2 light-years from Earth. To put it in perspective, if you could beat the universal speed limit and travel at the speed of light, you would arrive in less than 4 years, about the same amount of time it takes for your favorite show to fall into reruns. But let's dig deeper into why this proximity is so significant. We're talking about a universe that spans more than 93 billion light-years from one end to the other, so finding a planet so close and so promising for scientific investigation is like finding a gem in a pile the size of Mount Everest, a pearl that perhaps holds secrets about life itself. In the grand tapestry of the universe, Proxima b is a multi-layered mystery, offering us significant clues that could reshape how we understand habitability and life beyond Earth. It's not just Proxima b's proximity to Earth that excites scientists, but also the tantalizing signals that this planet isn't just Earth-like, but perhaps Earth 2.0. Proxima b sits comfortably in what space experts call the habitable zone of its parent star, where conditions are neither too hot nor too cold, but just right for liquid water to exist. Imagine waterfalls, meandering streams, vast lakes, and maybe even seas as deep and mysterious as the Mariana Trench. But before we start dreaming of traveling to Proxima b, we need to consider some peculiarities. For instance, a single day on this charming exoplanet lasts an astonishing 11 Earth days. Imagine sunsets that stretch into another day, slowly resisting giving way to midday and twilight, creating long hours that photographers would envy. While it sounds idyllic, it also has major implications for its environment and habitability. How would human biorhythms adjust to the patterns of light and dark on Proxima b? Would we need to eat 3 or more times in a single day on that planet? Would we sleep the same way on this entirely different world? The key elements of life as we know it would be tantalizingly similar yet strangely alien. It's as if nature is giving us a puzzle wrapped in a mystery, challenging our understanding of what makes a planet habitable. You might wonder how we can gather accurate, reliable data about a world we have never visited. The James Webb Space Telescope brings all its capabilities like a giant Swiss Army knife. It's more than just a telescope. It's a sophisticated research lab in the vacuum of space. Thanks to its advanced technology, space experts can not only observe planets but also analyze them through a lens of scientific instruments that would make CSI labs look simple. Using advanced spectrographs, the Webb telescope can study the light transmitted and reflected by these distant planets. Each element or molecule in a planet's atmosphere absorbs or emits light at a specific frequency. By focusing on these patterns, experts can perform a remote biopsy of celestial bodies, determining not just air pressure and density but also the possible presence of compounds essential for life, like water, organic carbon molecules, and even oxygen. It's not just cosmology, it's space forensics. We don't passively wait for signals to reach us. We actively search them out, examining the atoms and molecules that make up these complex worlds. The Webb telescope isn't just an eye in the sky. It's a highly specialized research facility, an expert, and a cosmic detective all in one. It allows us to turn our theories and hypotheses about alien worlds into methods for confirming or disproving them, changing our understanding of what might exist beyond our blue dot. When you thought you had uncovered the most mysterious layers of this vast cosmic tapestry, the journey is just beginning. As we stand on the verge of limitless discovery, the James Webb Space Telescope represents a beacon of hope and progress. Its powerful instruments are designed to delve into the most intricate details of distant worlds, revealing aspects of the universe that were previously beyond our grasp. The JWST's ability to examine exoplanet atmospheres extends our journey into the farthest corners of space, offering insights not just into whether these planets could support life, but also how life could emerge under different conditions. One particularly fascinating aspect of this research is the potential to detect biosignatures in the atmospheres of exoplanets. These biosignatures, such as specific atmospheric gases or chemical compositions, could serve as indications of biological processes. For example, detecting a combination of gases like methane and oxygen could suggest biological activity, as these substances often result from life processes on Earth. The JWST's advanced spectrographs can detect these subtle signs amidst the vastness of space, offering a new window into the potential for life beyond our solar system. Moreover, the search for exoplanets has introduced us to a variety of planetary systems with unique characteristics. Some exoplanets have been found in binary star systems, where two stars orbit each other, creating complex gravitational conditions. Others orbit red dwarf stars, which are cooler and dimmer than our Sun but potentially capable of hosting habitable zones.